Hey there, Primary 7 candidates. Welcome to this special Maths Explainer. I'm absolutely thrilled to be with you today. We've got one clear goal for this session: mastering whole number bases for your upcoming primary leaving examinations. Whether you're sitting in a classroom right now or revising at home, we are going to completely demystify this math topic together. So grab a pen, grab some paper, and let's get ready to learn. So let me ask you a quick question to kick things off. What actually happens when we step outside our normal way of counting? You know, since you were way back in nursery school, you've been counting in tens. 1, 2, 3, all the way to 10. But what if the rules completely changed? What if we were only allowed to use a few specific numbers to count? Well, that is exactly what we call working in non-decimal number bases. Let's dive right in and see how this works. We've got a quick 6-step lesson plan today. We'll start with what number bases actually are, then move on to changing base 10 to other bases, going in reverse, converting between two non-decimal bases, and finally, we'll tackle adding and subtracting in these bases.
All right, part 1. What exactly are number bases? Let's define the system.
Simply put, a number base is just the counting system we use to build our numbers. You know, our normal, everyday system, that's base 10, where we use digits 0 through 9. But in base 2, which is also called binary, we literally only use 0 and 1. In base 5, we just use 0, 1, 2, 3, and 4. We've also got systems like base 8 and base 12. Now here is the golden rule you need to remember. The digits used are always smaller than the base itself. Moving right along to part 2, changing base 10 to other bases using the division method.
Let's look at a classic example you'll definitely see in your P7 curriculum. How do we change the number 25 into base 7? I want you to think about this like packing items into boxes. If we have 25 loose items and a base 7 box holds exactly 7 items, well, how many full boxes can we make and what's left over? To find out, we just have to divide. Here's the step-by-step. First up, we divide our number, 25, by our new base, which is 7. Okay, 25 divided by 7 gives us 3, with a remainder of 4, right? Since 3 is smaller than 7, we literally can't divide it anymore. So the crucial trick here is how we read our answer. We always carefully read the remainders to form our new number. So we take that 3 and that 4, which gives us our final answer, 34 base 7. And a quick tip for the exam, always remember to write the name of the new base in words at the bottom.
Okay, part 3, going in reverse, changing other bases back to base 10 using place values. So let's figure this out together. How do we change 234 base 6 back into our familiar base 10? Well, to undo that division process we just learned, we actually have to use multiplication and our place values. Think of your normal place values, ones, tens, hundreds. But because we are in base 6 right now, those place values are going to look a little bit different.
Setting this up in a simple table makes it super easy. Write down your digits, 2, 3, and 4. Now, right below them, put their place values. In base 6, starting from the right side, the place values are 1s, then 6s, and then 6 6s, which is just 36. Now you just multiply the digit by its place value. 2 times 36 gives us 72. 3 times 6 gives us 18. And 4 times 1 is just 4. Finally, add those values together. 72 plus 18 plus 4 gives us a beautiful, perfect sum of 94 base 10.
You're doing fantastic, candidates. Now for part 4, changing between two completely non-decimal bases. Okay, here's a real challenge. How do we change 123 base 5 directly into base 6? Spoiler alert, you can't just jump straight from base 5 to base 6. It just doesn't work that way. But don't worry, there's a super handy bridge we can use to cross over safely. And that bridge is base 10. Step 1. Take that first number, 123 base 5, and convert it into base 10 using that exact place value method we just did. When we multiply those digits by the base 5 place values, we get 38 base 10. Now for step 2, we're standing right on the bridge. We take that 38 and convert it into base 6 by dividing. 38 divided by 6 is 6, remainder 2. Then 6 divided by 6 is 1, remainder 0. When we write down those remainders, our completed journey gives us the answer 102 base 6. Always use the base 10 bridge.
All right, part 5, adding in different bases. Let's talk about the grouping rules.
Imagine sitting in your exam and seeing this question. Add 225 base 6 and 434 base 6. What do? If this were normal base 10, we just add them straight down, but I want to remind you of our golden rule. In base 6, you can never ever write down the digit 6 or any number higher than 6. If your addition gives you a 6 or more, you have to group them. Let's check out the math.
Let's walk through it step by step. Start in the ones column on the far right. 5 plus 4 equals 9. But wait, we can't write 9 in base 6. So we divide 9 by our base, 6. That gives us 1 remainder 3. We write down that remainder, 3, and carry the 1 to the next column. Now the middle column. The 1 we carried plus 2 plus 3 equals 6. Divide 6 by 6. That's 1 remainder 0. Write down the 0, carry the 1. Finally, the left column. 1 plus 2 plus 4 equals 7. 7 divided by 6 is 1 remainder 1. Write the remainder 1 and carry the 1 down to the front. Our final answer is 1103 base 6. So the pattern is add, divide by the base, write the remainder, and carry the quotient.
And finally, part 6, subtracting in different bases, and the very special borrowing rules. Try tackling this problem, 671 base 9 minus 285 base 9. Right off the bat, looking at that first column on the right, you'll see we have to subtract 5 from 1. Obviously, we can't do that, which means we have to borrow. And guys, this sets up absolutely the most important math rule of this entire explainer. Pay close attention here.
Here is the big secret. When you borrow in your normal base 10 math, you're borrowing 10, right? You bring over a 10 and add it to the digit. But when you borrow in a non-decimal base, you borrow the exact value of that base. So in base 9, when you borrow from the neighbor, you are bringing over exactly 9. You add 9 to your digit, not 10. Let's see this in action.
Let's walk through the exact math. In the right column, 1 minus 5. Impossible. So we borrow from the 7 next door. That 7 drops to a 6. The amount we carry over? Exactly 9. We add that 9 to our 1, which gives us 10. Now we can subtract. 10 minus 5 is 5. Beautiful. Now for the middle column. We have a 6 sitting there now, minus 8. Still impossible. We borrow from the next column, turning that 6 into a 5. We bring over another 9, add 9 to our 6, giving us 15. 15 minus 8 is 7. Finally, the far left column. 5 minus 2 is 3. Our answer is 375 base 9. Just remember the golden rule, always borrow the base. You have done an absolutely fantastic job following along today. To wrap things up, I've got a final PLE revision challenge straight from your topical exercises to test your new knowledge. What is 111 base 2 plus 11 base 2? Write it down, remember your carrying rules, and remember that in base 2, you can only ever use zeros and ones. So what's your answer going to be? Keep practicing your whole numbers, trust the process, and I warmly wish you the absolute best of luck on your primary leaving examinations. You've got this. Until next time, keep learning and keep practicing.